Assalamualaikum guys. Today I will be teaching you the introduction to electrical transient analyzer program through ETAP 6.0 software. The components of one line diagram we are using here are 3 generators, 4 transformers, 3 static loads, 3 induction motors, 6 AC buses and transmission line. This is what you can see the final output of our tutorial today. So let's start over on the right side of the canvas. On the right side of this ETAP software, you can see the toolbars, and when you take the mouse over any of the tool, on mouse over it will show what exactly the icon denotes. So let's start by putting 3 generators. I click the icon and then I click here, or I just drag and drop the icon over here. 3 generators are here. Then we will use 3 transformers. We will use 2 winding transformers, and we will use IC symbols for them. So right click the transformer symbol, go to symbols, and then select IEC. Do the same with all the 3 transformers we have selected here. Then we are going to put our buses. 3 buses over here, 2 buses over here. Yes, okay, it's fine. Then DC load and induction motor. Here it goes the DC load, and here is the induction motor. Click the bus icon and move towards the right end of it, or its right end, and then you will see the movable cursor icon and make it longer. Here it goes. Do the same with the other buses wherever you require to make the length a little bit larger. Now take your mouse over the icon of the IEC symbol of generator, and you will see a pink square box appearing there. When that square pink box appears, just click and drag it towards the bus. You will see the bus goes pink when you will come over it, and then leave the mouse. It will connect it to it. It will connect the generator to the line, the bus. Do the same with all other components. Yes, we are done with half of the image. So here is a little tip. If you want to, we are going to put these 2 icons over here. I will just select them. I will press Ctrl C to copy, and then Ctrl V to paste, and they will get replicated over here. Then I will drag them towards this bus 14 and connect them to the specific bus I just mentioned, and connecting the transformer 7 over here, and then to the bus 11, and then generator to the bus. Similarly, we will do the all the process over here. Here we will, let me see what, 2 buses, 1 transmission line, transformer, low and this. Okay. Drag the bus here, click it, right click it, and then rotate to 90 angle. Move this text below because we are going to change the dimension, so it must not overlap our line, transmission line. Then we will introduce the transmission line from this tool. We will use the IC symbol. We will rotate it to 90 degrees and then we'll connect it. Another bus over here, similar procedure, rotate it to 90 angle, take these texts below the line and connect it to the transmission line. You can beautify the circle. I am just making a rough sketch in this tutorial. After this transmission line, we have a transformer, winding transformer over here. Make its symbol to be an IC symbol. Rotate it to 90 degrees and connect it to the bus. Then after it we have the similar procedure like this one, and we will copy it and then paste it. And we'll move it here. Here you go. We are almost done with our visual image. Now let's set the parameters to these components we have just devised. Let's start with the generator 4. Double click it. I'm talking right now I'm talking about the left click. Just double click it. Go into the rating tab. Just set it to something like 100 and kV to like 6.3 and press OK. One thing I forgot, double click it. After rating, go to the grounding model. We are going to ground it with Y configuration, and we will show the symbol visually on this canvas by clicking this symbol icon, symbol radio button. Here it goes. Similarly, double click the transformer 6, go to the rating. Let's set it to 6.3 primary and secondary to 0.415. Make its MVA to 50 MVA, and then grounding, make it both Y and show the symbols. Here it goes. Keep arranging them. Static load over here, 10 MVA load. We are going to introduce 10 MVA. Just press OK, and then we will set the parameters of our induction motor. Go to the nameplate, select 500. Just write here 500 here and press OK. Now comes the generator 5. Let's make it 100 MW and then 6.3 kV. Grounding must be visible. Then transformer 7. 6.3 primary with 0.38. These values are just custom values. I am just inputting them here. You can use any values of your own custom demand here and make it 10 MVA. I'm making it. Forgot, from grounding tab, make both of them to Y and then show symbols. Let's double click this DC static load. Okay, its rating must be 2 MVA, something around it, and it's grounded by configuration. In this motor, go to the nameplate tab for 200 HP. Yes, here is a bit tricky to find. It asks for typical nameplate data. Select NEC standard. all goes over here. Afterwards, the last loop over here of transmission line, the generator will be set to the megawatt of 200 kilowatt to 11. I can take it to 11 and then show the grounding symbols. And the transformer 8, its rating must be something around 6.3 for primary growth, and then 132 for secondary, and making it 50 MV. So grounding must be visible, making Y and secondary, let's make it a delta on secondary. There it goes. After it, let's move towards the last transformer here, and we will rate it like something around 132 kV, and secondary must be like around 11 kV. Put at 26 MVA, and I will show the grounding over here. Make it second using delta. Here it goes. The last loading must be like 12 MV. And the last motor nameplates, let's make it 100 horsepower. Again asking about the standard, and we are checking anything and then pressing OK. And here it is, we are completed with our diagram of the circuit we were talking about. See ya. Allah Hafiz.